on this computer here. Great. And so I want to start up I want to pick up where we left off last time. And we were talking last time about tables. And so I want to finish that, that part of that. And so let's do a little demo. Let's see if I can get the one. Great. All right. Fantastic. Everyone can see my screen okay? I will take no news as good news. And so, yeah, so we talked about tables, and we're going to talk a little bit today. Hello?
We
Sorry,
can't see it yet.
your screen.
You can't see anything?
No.
Yeah.
Oh, how sad is that? Let's try that again. Thank you, everyone. That was good real-time feedback. Okay, Chrome. How about now?
No.
No.
Nothing.
How come? Oh my goodness, this is truly troubling and puzzling to me. It's telling me I'm screen sharing.
It shows up on the screen that you have started screen sharing, but then the screen itself doesn't pop up.
Okay, all right, let's just do this for now. Maybe it's, how about this? Do you see my desktop now?
Yes.
You see everything? Okay, all right, fantastic. All right, sorry about that. So, we're going to do just kind of a review, a demo again in Jupyter Notebook, right? You all have accounts. And oh, by the way, the first homework has been posted. And so if we go to the class website, you can see under the assignment section, and you guys can all see this window, right? You can see the class website?
Yes.
Awesome. If you click on homework 1, that will automatically launch Jupyter Hub for you. And basically it copies all the files and starts up Jupyter Hub for you. And then it's just a couple of questions to give you some practice. And you have a week to do the assignment. So the assignment is going to be due Wednesday at 11:59 p.m. So kind of the way the course is going to be setting up. So we'll have our labs, and the labs are really practice. The labs are kind of practice, and it's okay to help each other out with the labs. Like if you're stuck on something, ask me, ask a coach. We've started to get our coaching assignments in, so I think we'll have some coaches in the lab with us on Friday, and we'll have some monitoring the remote channels. And so the labs are really kind of the way to get practice, ask for help, from us, from the coaches, socially distanced from your neighbors in the class. And so that's really kind of, and the labs really, we kind of check them off as kind of you've completed the lab, and they don't really get a grade. They get kind of a check or a not check. And the idea is that the labs, a good chunk of the lab you should be able to get them done during lab period, but don't fret if you can't. If you can't finish during lab period, or for whatever reason you can't make a lab period, you can do the labs on your own, and then when you're done, you can just message us on Slack, and we can look at your files and check you off. So the labs are really kind of you do them or you don't, and then the homework will actually get grading. And so that's the homework is kind of more of your individual effort, and it's okay to talk to us and the coaches, but this is the one where kind of sharing screens with your neighbors, you don't want to do that for the homework, okay? And so that will be due. And you can also, the part of the reason why I want to release the lab, the homeworks on like Wednesday night, Thursday, if you have questions, it will give you some time to look over the homework. And if you have any questions during lab period, we can also answer questions about the homework as well as the labs. Okay, so that is the homework. So let's get back to the tables. And so again, we're going to have kind of at the top of a file, a little bit of boilerplate. And we'll talk, as we learn a little bit more about Python, we'll talk about what these lines actually do. But for now, it basically gives us it gives us a functionality that we're going to use in our program. And the two big packages that we'll use a lot of is this data science package. And that's going to give us tables and allow us to do operation on tables. And then the other one there is something called NumPy. That's short for numerical Python, and that's going to give us some mathematical functions that we'll use from there. But for now, we just we just need to remember to run that cell. So if we run that cell, and then we're going to create a table, and we'll look at a couple of different ways of creating tables. One of the easiest ways of creating a table is actually just reading a CSV file. A CSV file is a text file. CSV stands for comma separated values. And you can actually see this NBA salaries. And so if you go and click on up in the upper left-hand corner, the Jupyter, that's fine. It's just, here, I'll save my work, so it won't give me that error or that message. So if I leave here, this will show you all of the files, and all of the files for this class are going to be in this directory, this data 144 material spring 21. These are all your files. And so when you click on that link on the web page, it's your homework and your labs and your demos, they all get copied into this directory. And you can see there's 3 folders here: homework, labs, and lecture. The lecture are the in-class demos. So if we click on that, we can see here are all the particular demos. And down at the bottom, you can see here is the file, the actual CSV file that we're going to be reading in with that table function. And so if you actually just click on it, you'll see it's just a text file separated by commas. And then the first line is special. It gives the name, it's called the header for all of those. And you can see it's just a text file with our data. Okay. All right, so let's go back to our demo. Review tables. And so here, what we're doing here is, and we'll talk a little bit later today about types, but a table is an object that we get from importing the data science library. And so this table is an object, and we can call functions on objects. And so what this line right here is doing, it is calling the table part of the data science library, and it's calling this method called read table. It takes one argument, the name of the file that we want to read, and then we're doing something here, and I'm going to explain this a little bit later. This is called function chaining. But basically, the way I want you to think about it is that this first part right here, what that's going to do is that's going to open that CSV file, and it's going to create a new table object. Can you make the screen bigger with a Control+? Absolutely. Give me 1 second here, see if I can do that. How's that?
That's amazing. Thank you.
No problem. Thank you for letting me know. I'm on this big 30-inch monitor, so it probably looks a little smaller, like on a 11-inch laptop or something along those lines. So thank you. I will remember that setting. So what am I doing? I'm doing about 150. That seems to work well. Excellent. So what this line here is doing is that this is opening that file, and it's creating a new table object. It's creating a new table object, and on that table object, we can call certain functions on that table. And this function, one of the functions that we can call is relabel, and that's going to just change the name of one of our columns. And it's going to, in particular, the way this works is it's going to change the third column to whatever it was to salary. And if you remember, if you happen to notice when we looked at the CSV file, the header for that column is like salaries 1516. And so that's just giving it a kind of a more human readable name. So if we run that cell, and then you can see what Jupyter Notebook does very nicely for us is when we load in that table, we've now assigned it, we've given it the name MBA, so we can use that later in our code. And so MBA, that that name has a particular type, and that type is a table. And Jupyter Notebook very nicely kind of displays the first 10 rows of the table for us. And we can see player, position, team, and then our relabeled or our renamed salary column. Okay. Now that we have this table, we can call different functions, different operations on that table. And we do that by using this dot notation. So if you look at this line right here, you can see NBA is our name. It's the name of our table. So it is a table object. And one of the operations, one of the methods or functions that we can call on tables is where. And what that is going to do is that is going to show us, it is going to show us all of the rows where the position, so the first argument to this function is a column name. It's going to show us all of the rows that have the position matching the string PG for point guard. Okay, and we're going to save that. We're going to save that. We're going to save that table. So this operation returns a brand new table, creates a brand new table. So point guard will also be a table, just showing us the particular rows that match the criteria. So if we run that, we didn't see any output because the assignment, right? We're taking whatever is on the right-hand side, and we're giving it the name on the left-hand side. Even though this is an equal sign, it's not like a mathematical equation saying that these things are equal. What it is an assignment. And the way assignments work in Python is whatever's on the right side of the equal sign, whatever's on the right side gets evaluated. Whether that is a number, a string, a table, some other object, this whole thing, this is an expression that gets evaluated. And in this case, this expression calls this function, and then whatever returns from that function we're going to give it the name point guards. And so point guards is a table. And so if we want to see the contents of it, we can just run a cell with it by itself. And by default, Jupyter Notebook will show us the value of that. And the default for tables is to show us the first 10 lines. And so if you notice, this was our original table, right? The first row in it was this was this player Paul, and then Al, and then so on and so forth. And you can see now the table, it's a different table. All of the rows all have the position point guard because we've told it to give us only the rows that the position is as point guard. Okay, and you can notice the table is much smaller, right? You can see that we gave the first 10 lines here, and then it says 407 rows have been omitted. And down here, because we're only selecting the point guards, we have the table has 85 rows in it. Okay, any questions about that? So that allows us to select rows that match a particular criteria.
Question.
And now, yes.
So just the first, I guess it was cell number 2. Why did that have an output if it's just an equal sign?
Great question. So the question is, and the reason why is because of this line right here. All right, if we take this out and run this cell again, you see that there's no output. And the way the Jupyter Notebook works is that it will run every line in your cell one after another in order. And so in this case, what we're doing is we're running, this cell has 2 lines of code in it.
Oh, gotcha.
And so by convention, what Jupyter Notebook does is it only shows you the last output. It only shows you the output from the last command. And so, for example, if I left this line just like this, and then I did something just like an expression, if I just did 2 + 2, right? You can use Python as a calculator. And so when I run this cell, it's not going to show me the NBA table. It's just going to show me the output from that last line, which is going to be, hopefully it should print us 4 from there. Okay. And so this is really a Jupyter Notebook convention. If you actually want to see the output of something after an assignment, you just have that name by itself. And this is really doing nothing other than displaying the contents for us in that cell. The assignment is actually the important line here. Great question. Thank you. And so, for example, and so we can see here, if we run this, we are going to get the output where we're going to drop a particular column. So notice that the drop method, again, operates on tables. It's going to take a string, which is going to be the column name. Like, for example, if we mistyped this and we ran this function, notice it didn't give us an error. And that's kind of by design. What it's really doing is it's checking to see if there is a particular column with that name. And if there is, it will drop it. If there isn't one there, it doesn't give us an error. It's just not going to do anything. Notice that this is the same, has the same number of columns as before. So that's something to kind of watch for when you're writing your own code. If you have like a typo, it may not exactly do what you think it is. And again, Python is a case sensitive language. And so if we did position all in lowercase, notice that it did not drop that column. It did not drop that column because Python is case sensitive. It's gonna do an exact match. And so when you're writing your own code, those are things to kind of keep in mind. From there, okay? And now, interesting, okay, so now here's a test to see kind of what's going on. So I did this point guards drop, right? And so it evaluated this expression and it's the only line in the cell, so it showed us the output. What's gonna happen when I run this cell? What's gonna happen? Is it going to show me this column? Is it gonna show me this table, the one with the drop column, or will it show me this column up here?
It will show the one with position because you didn't reassign it.
Yes, yes. So if we show this cell right here, the position came back, and that's exactly right. And that's a good thing to keep in mind, is that this whole thing is calling the drop function on this table. The output is a brand new table. It creates a brand new table. It doesn't touch your own table. And we saw examples of that on Tuesday as well. And so if I wanted to keep this table and use it in a future calculation, I would assign it, I would give it a new name. I would give it a name from there. So great. And here's an example for that, right? To keep that table around, we're gonna put it as part of the assignment. And so now, the point guard table, we've created a new table and we've given it the name point guards. And so we can do things like, now that we have that, we can sort by salary. And this show here, so again, this is an example of function chaining. And so we're taking the point guard table, we're going to sort the table on salary in descending order. And then by default, if I leave this off, what it's going to do is it's going to create a table, it's going to create a sorted table, and it's only going to show me the first 10 lines, okay? And so what we're doing, and so kind of the way I want you to think about it is that there's a bunch of operations, there's a bunch of functions you can call on tables. This whole expression, when we run it, what does it do? It creates a new table. It creates a new table, and that table we can actually call functions on as well. And that's exactly what we're doing with this dot, whoops. It's all gone. There we go. Hey, it's back. That's exactly what we do when we put this dot. So think about everything, think about what type is everything here, right? So point guard sorts returns a table. So what operations can you call on tables? Show is one of them. And what show is going to do is that will just simply show us the entire table from there. Okay, So that's where that comes from. This is an example of function chaining. You'll use it a lot just to save yourself some typing. We could easily just, break that up into a couple of lines. And sometimes if you're chaining a bunch of operations together and you get like 3 or 4 of them chained together, your code starts to look a little unwieldy. It's just long. That's usually a good idea to kind of break it up in save one of the intermediate tables, give it a name, and then do the operations on that. The computer doesn't care, but one of the things that I'd like you as a computer science, me as a computer scientist, one of the things I'd like you to come away with is writing code that is easy to read and maintain. So this is the sort of thing where if you come back to this code 6 months or a couple months later, you can actually look at your code and go, oh yeah, I remember exactly what I did. And that's a big reason why we give these expressions names. So they're really human. They're really for us. They're really for us to kind of remember exactly what we're doing from there. Okay, and so here's an example of a lot of things chaining together. And so the key to kind of reading these chained functions is really just start at the left and figure out what each step in the chain is doing. And so here what we're doing is we're taking our NBA table and we're getting all of the rows where the position is point guard. Okay, so that's going to create a table. That's going to create a table with just the point guards in it. And now, since we know we just have point guards, we're going to drop, here's the second part of the chain, we're going to drop the position column because we know we just have point guards. And then finally, the last thing that we're doing here is we're sorting by salary, and then we're doing in descending order. So highest salaries first. And since we don't care for this example, we're just wanting to look at the top 15. Okay, so this is the equivalent of doing all of these individual operations one at a time, saving each one in its own table. So we run that, we can see that's exactly what it's doing. It dropped the position and then sorted our salaries from there. Okay, and then let's see, what are we doing? This line looks exactly the same from there. And it should give us the exact same. Oh, what am I doing? Why? All right. What? Let's see. Position where? Oh, okay. So the difference in this line here is it gets back to the fact that Python is case sensitive. So here we're setting. We're trying to select for the position point guard. And so in this example, because it's matching on a particular column, there's no column matching. So this is not going to actually give us a table that we can do with that we can drop the position on. Okay. From there. And again, that will give us an error as well. So the really kind of takeaway from those last 2 cells is Python is case sensitive, and you got to match the column names exactly from there. Okay, great. All right, so let me stop sharing there. And I think that kind of wraps up our review topic. So what I'm going to do is I'm going to stop the recording on this computer. Fantastic. Okay, so we've been introduced to a bunch of different types so far. We've looked at the table type. We've talked briefly about numbers. And so let's kind of revisit them a little more in depth. So we're going to talk about numbers, and numbers are important, right? For data science, and computers, we pretty much a lot of the time work in numbers. So it's a good place to kind of start thinking about how do we represent things in our system. Okay, so there's a robust set of operations, arithmetic operations, right? Computers are really good at doing arithmetic. And there's a kind of all the usual suspects. We have addition, subtraction, multiplication. And the good news is they all work, and division. So addition, subtraction, multiplication, and division, they all work exactly as we expect them to work. There's one little twist. There's one little interesting thing too, is that so division works exactly as you would expect it to. Like 7 divided by 3 is going to return to you a floating point number, a fraction number from there. But Python also supports something called integer division. And notice the 2 slashes, that's not a typo. The 2 slashes will actually do integer division. And what that means is that notice, right, 7 divided by 3 is, so 3 goes into 7 2 times and, some change, right, 2/3 from there. The integer division is just going to give you the integer part. It's just going to give you the whole number part. So 7, so 3 goes into 7 2 times, and that will just show you the whole number part. It basically ignores any remainder. And if you actually wanted the remainder, you can use the remainder operation, which is the percent sign. It's also known as the modulus operator. And that actually gives you the remainder. So if you do 7 modulo or remainder 3, that's going to give us the fractional part of it, right? So 3 goes into 7 2 times with 1 remainder left over from there. Okay, and then the other one, we saw this kind of in the lab, explanation. I'm not saying that right. Taking the exponent of something, raising something to the power, and that is 2 stars right after another, right? So 1 star is multiplication, 2 stars is explanation.
Quick question.
Yes.
I wanted to talk, this is just, I guess, more of a general question, but I wanted to ask about the importance of spacing. Just because I see, like, sometimes it's hard for me to tell if that integer division is like a space between the 7 and the first bracket.
Great.
Important.
Yeah. No, that's a great question. Python is a little more sensitive to spaces than other languages. And we'll as we learn and as we start writing our own functions and more complicated code, we'll get into that. But in this case, there is no space. There is no space between the two of them. And in general, symbols will not have spaces with them. So spaces are in general used to separate things. And so when we think about names, when we think about naming things in an expression, there's actually a couple of rules about that. And one rule is that your name can't have any spaces in it. And those spaces are important because that's how Python knows when one symbol ends and another one begins. And so here, between the 2 stars, there's no space. Between the 2 slashes, there's no space. So here in these examples, the space is optional. So you can have 2 plus 3, and you can have space. You can have a space after the 2 and a space after the plus. You can have multiple spaces as well, or you can have them together. And the reason why you can have them together is that Python knows that that 2 is a number and that plus is a mathematical symbol, and it can disambiguate them from one another. And by the way, because of that, in Python, names cannot start with a number. Names can have numbers in them. So you can have a name that has a number in it, but it can't start with a number. And that's just so it makes it easier to know whether you're dealing with a number or a name from there. Okay, great. Did that answer your question?
Yes, it did. Thank you.
Awesome. Okay, so let's take a look at a demo where we can see some of this in operation. All right, and again, we'll just run our particular cells. And so we can just use Python as a calculator, and we can just type numbers. And what's going to do when I evaluate this cell, it's just going to see the number 30, and then it's going to evaluate that expression and give us back 30. Here we can do mathematics. We can do operations. This is just multiplying 10 times 3. Dividing. Again, it's going to do regular division, so it's going to turn in 3.333333. So notice, right, because we're writing things as decimals, notice really at the end here, this is not exactly right what you would expect. What is kind of the mathematical answer to 10 divided by 3? Well, it's 3.33333333 forever and ever and ever and ever. But as we see is that for floating point, for fraction numbers, these are called floating point numbers in Python. They're represented by they have a certain amount of precision associated with them. And how precise you can represent fractional numbers depends on how big the number is. But you can see down here, that is not quite right. But how many decimal points are we going at? We're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 places. Okay. So for all intents and purposes, this is pretty equivalent. We're going out 16 decimal places before we get kind of a difference in there. But just be aware that, if you're dealing with very, very precise numbers, there's a limit to the precision that we can represent in a computer. The good news is for this course, we really don't have to worry about that too much. But I pointed out just to be aware that this is normal. This is not like a bug in the system or anything. So we can do division. And so notice, right? So 10 is a whole number that's known as, in computer science, those are known as integers. And so is 2, but when we divide the two of them together, even though it comes out as a whole number, the result of the division operation in Python will always return you a floating point number, will return you a fraction. And that's why you see that the answer is not 5, but it's 5.0. And when you're looking at the value of an expression, that's one way you can tell whether it's a floating point number or an integer based on whether it has that decimal point associated with it. Okay, here is showing an example of raising to the power. So this is the equivalent of 10 times 10 times 10, which should give us 1,000. And this exponent does not have to be a whole number. It could be less than 1. It could be a fraction. And in this case, right, taking something to the 0.5, so 10 to the half is the equivalent of taking the square root of that. Okay. And so if you multiplied 3.1, all of that together times itself, you should get back 10, right? We can actually do that. That's a fun little exercise. If we add a cell here, if we actually, I'll just cut and paste this, we do, and we multiply that again, evaluate that. Interesting, right? We got close to 10. And we got 10 point, all the way out, right, to the 16th decimal point again. Again, this comes from the fact that this is not the perfect square root of 10, right? The square root of 10 goes out for infinite number of digits, but this is pretty darn close, right? It's good enough. And then, so while there is a limit to the precision of floating point numbers for fractional numbers, Python's integers in Python can expand to be as big as you need them to be. So here we're taking 1, 2, 3, 4, 5, 6, which is a fairly large number, and we're raising it. We're taking that and we're taking this number times itself 890 times. I don't know what the answer to that is, but I know it's a darn big number. And so we run that. What do we get? We get, guess what? A darn big number. And look at that. Python was actually able to do that calculation and show us in all of its many, many, many digits glory. Okay. So while there's there's a finite precision to fractional numbers, integers can grow without bound as needed. 10.3, 3 point, right. Again, I show you that. And so here's another example. We saw this limits the precision when we squared, we took the square root of 10 and then multiplied it by itself to get the original back. We can also do another example here is if we have some number with a lot of decimal points, right? So we're writing them out, so it has a lot of precision. If we evaluate this expression, what we get back is something a little less, right? So here's our number, here's our whole number, and here's our fractional point, but it really just kind of stopped at this point. And remember how I told you the precision, how many digits of precision you get really depends on the size of the number as well. So this number is a fairly large number. So we got a little less precision than we did up here. Here you can see all the decimal points going on. And what Python did was just basically round it at this point from there. Okay. So, but what that means is if we go back to our original, and then we subtracted this, right? So you can see if we actually did this in pure mathematics, we should get some small fractional remainder. But if we run that here, we actually get 0 because we've exceeded the precision limits of representing this, this fraction, this floating point number. Any questions about that? Make sense? Really, the kind of takeaway is that at the very end, you know, there's a limit to the precision from there. But again, we're not really going to have to worry about that too much or at all for this course. And again, another example here of just not getting back exactly what we started, but it's pretty darn close, right? From there. Okay. So what are we doing here? So here we're taking 10 divided by 5. That should give us 2, but that's a floating point number. And here we can convert things to an int. Okay. So 10 divided by 5, converted that back out. What happens if we try this? Interesting, right? So if we divided 10 point, if we didn't do the conversion to an int, what do we get? 10.4, we get 2.5. And you can see what the int does is it converts to an integer, but it actually just ignores the decimal point. It truncates. And so, for example, if we put int 9.999, right, it is not going to round for us. It is not going to round for us. It is just going to give us the integer part of that number. So that's something to kind of be aware of. And by the same token, we can convert a integer into a floating point number, and that should give us 3.0. Okay. The other thing we can talk about is that Python supports scientific notation for writing really big or really small numbers. And so if we divide 6.4, we get 1.5. If we keep making the denominator larger, our number is going to get smaller and smaller. Okay. And so instead of writing out all of these zeros, Python will helpfully show us the result in scientific notation. And so here's our base 1.5. And then the E is just times 10, right? So this whole thing is 1.5 times 10 to the minus 56. And so really kind of the way you want to think about it is that minus 56 means we're going to move the decimal point. We're going to move the decimal point 56 places to the left. Okay. And you can see if we take what we just did and multiplied it by back, this was our denominator, and we multiply it by this small number, we got back exactly where we started from. And you can type as an expression it in scientific notation from there, and it will understand that too. And I believe it will also accept a capital E. Yep, it'll accept both from there. Okay. Here's an example of assignment. And remember, though, the mental model I want you to have an assignment, because it can trick some people up. If you start thinking of it as an equation, it is not an equation. It is literally a very mechanical process assignment. And I want you to think about assignment is having the left-hand side, which is always a name. The left-hand side is always a name. And the right-hand side is some expression that evaluates to a value. And so here we're evaluating the expression, which has the value of 5. And then we're giving it, we're storing that under the name X. We're actually storing the value 5. We're not encoding any other variable. Like if there was like another variable or something in there, we're actually computing the value of that expression. We're computing the value of that expression, and that number or object or type of whatever, depending on the variable, that is what is associated with that name. Okay. And this thing here, and so that this is just giving it a value, right? It's going to return nothing. So the thing to remember is that even though we can do a lot of computation in Python, it is not like algebra. It is not kind of mathematic, like 2x, right? That's something we could see in like an equation, and we know that a 2 followed by x would be 2 times x. This is not valid syntax. Remember what I said, that all variables have to start with a name. It is going to get very confused that there is a number here and this name, and there's no operation in between. This will give us an error. And in some cases, it's just, a very generic error, syntax error. It couldn't understand what we were doing. And so if really what we were trying to do, kind of in the mathematical equation sense of do 2 times x, we need to put the operator, the multiplication operator. And again, in this case, spacing is helpful for readability, but but Python doesn't care. We could easily just do 2 times x, and it's going to accept that just fine. Okay, and so since the converting from a floating point to an integer, if we call the int built in, the int function is built into Python. If we call the int built in, that just truncates. That doesn't do any rounding. There is a built in for round, and round will do exactly what you expect. It will round to in the default case, to the nearest whole number. And then you can also give an optional second argument, which is how many digits of precision do you want to round to? So this will give us 2 places, right? So here's 1 place, and then 1 after the decimal point from there. Okay. The other thing to kind of realize is kind of the result of operations. So here we have an integer. So we have an integer type, and we multiply it by well, because we have the decimal point there, this is now a floating point type. If we multiply an integer times a floating point, the thing we're going to get back is a floating point number. Okay. If we left this off as 3, the thing that we get back is going to be an integer. It's going to basically automatically convert because one of the arguments was a floating point number. Okay. Any questions about that? So supports arithmetic. We have a limited precision in floating points, but that precision is going to be more than enough that we're going to need for this class. And then just be aware of kind of some conversion and syntax. I think that's kind of the big takeaway from that. All right, stop sharing. Actually, no, I want to go back. So any questions? Hi. We're doing all right? We're all together. If you've seen some programming before, this might be a little slow. Don't worry, the pace will absolutely pick up. And if you haven't seen this before, this might seem too fast. That's okay too. We're going to give you practice. We're going to give you practice with the homework in the lab. So if you feel like things are going just at the right pace, awesome. If you feel like things are going too slow, things will pick up. And if you feel like things are going too fast, we're going to give you more practice. So hopefully that covers all of the major food groups. All right, let me go back to screen sharing just to make sure. Yeah, all right. So, okay. So at this point, we know 3 different types in Python. We know 3 different types. We know integers, which are represented as whole numbers and possibly negative. We have floating point numbers, which are fractional numbers, numbers with a decimal point, both positive and negative. And we know about table objects. We know about tables. We're going to introduce you now to our 4th type, and those are strings. And the strings convey data, convey text data. Okay, and so what is a string? A string is really just text of any length. And how do we denote strings? We put them in either single quotes or double quotes. And so this first example here is a string that has the length 1 that contains the letter A. We can, again, have strings of any arbitrary length as long as they're enclosed in either single quotes or double quotes. Python doesn't care, but you have to be consistent. If you start a string with a single quote, you have to end it with a single quote. And you can put anything in any text, any character in between these 2 strings, in between the quotes. And as a matter of fact, we saw in the first lab on Friday, we can even do things like have emojis inside of our text, inside of our string. If we have a string that represents a number, we can, there are conversion techniques that allow us to do that pretty seamlessly in Python. And so remember the int function, if we give it a string, it will actually try to interpret this string, this character, right? So because it's in quotes, that is a string. That is so the thing that's inside these parentheses here is literally the character symbol representing 1 and the character symbol representing 2. It is not an integer. It is a string with the characters 1 and the characters 2. To actually get it to be an integer, to go from an integer, you actually call this int conversion. And then that would return the integer, the actual integer with the value, the number with the value 12. Okay. And by the same token, we can convert floating point strings into an actual decimal number using the float built in. Okay. And any value could be converted to a string by calling the built-in str. That's short for string. So if we give it the number 5, that will return us the string with the character 5 in it. Okay. All right, let's take a look. Okay, so again, a string is anything enclosed in a single quote or a double quote. The choice is up to you. I would pick one and just be consistent with it. I think a lot of the examples use single quotes because you don't have, it's a little easier to type because you don't have to type the shift key. So this here, this whole thing, this expression evaluates to the string flavor. Notice if I leave the quotes off, what do I have? Do I have a string? No, I have a name of something. And in this example, we have not assigned, right, this, because there's no quotes, this is not a string. This is a name. This is a name to something that hopefully we previously assigned, because if we haven't assigned it and then we try to evaluate this expression, this will give us an error. This will give us an error. And actually, in this case, Python gives us a pretty decent error. It gives us a name error, and it says name flavor not defined, because we have not assigned it to anything. Now, if we did something like we could do flavor equals flavor, that works. That would that would work from there. But remember, a string of characters without quotes around them, that is a name. That is a named object. And if we haven't previously defined that from there, again, we say, like I said, we can have any string start with either a single quote or a double quote. We just have to be consistent. And so here's a good example to use double quotes if you actually have like something that is using a single quote inside of your string. Python will have no problem with this. But if you decided to use single quotes here, so what's going on? And the syntax highlighting in Jupyter Notebook is being kind of giving us a clue to what's going on here. It's being a little helpful. And so what's happening is that, remember, Python is thinking anything is a string in between single quotes. And so even though this is the phrase we want, don't always use single quotes, what it's doing is it's taking our starting quote, and then here, this apostrophe, it's taking as the end. So it now it is basically saying the string don is a string, and then now it's getting very confused because it doesn't know how to interpret the rest of this. This will give us an error. This will give us an error, right? It doesn't know what to do with this because it's thinking it's a variable. It's thinking it's a variable at this point, right up against the string with no operation in between. So that's why we're getting the syntax error here. Okay, you can do operations on strings. And one of the operations you'll see a bunch of times is something called string concatenation. And so it is literally adding the two strings together, and we'll make a new string, which is a concatenation of the two strings. And so notice we now have a new string, which is this string immediately followed by the second string. And you can have as many of these as you want. You can add them all up together. But one thing to note, if you were like doing it for like a name or something like that, right, it doesn't automatically add spaces for you. So if you wanted to have spaces, you would have to put them in. So notice this, what we're doing here is this expression has 3 strings. It has the string with the value Steph. Here, this is a blank space. And then finally, a name Curry. So if we add them all together, then we get a single string, which is the first string followed by the second string followed by the third string. Okay. So strings support the addition and concatenation. And this is kind of crazy. Strings will support multiplication. And this is kind of weird. It is weird, but sometimes it is actually useful. And what this does is it takes, so if we have a string, in this case, ha, and if we multiply it by 100, what it's going to do is it's going to create a new string of, the, in this case, ha, basically added to itself 100 times. And so we're going to get ha, 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 100 times from there. Okay. It's kind of a weird thing, but sometimes it's occasionally useful. So if we just had 10 from there. Okay. There's limitations to this, you know, because it's kind of a weird thing multiplying a string by a number. But again, if you think about, you know, the addition as being concatenation, multiplication is kind of a normal kind of extension of that. I just got a comment from you guys. What if you want to print an apostrophe and don't you have to put the yeah. So what happens if you really wanted to use single? I think the question is, and if I just please ask again in the chat if I'm not answering the question I think you're asking, what happens if you really want to use single quotes? And you can, and what you can do is you can escape the apostrophe, and to do that you do that by using a backslash. Whoops. Right, just like this. Okay. And so what this is saying here is that this whole thing is saying, don't treat this apostrophe as the end of the string, treat it as being part of the string. And if we evaluate that, that is actually gonna work okay for us, right? Notice the default in this case. What's interesting is that the default is actually replaced it, even though we specified it with single quotes. It actually just said, nah, you probably want to use use double quotes, easier to display. Hopefully that answers your questions. Hopefully that answered your question. If not, please pop something else out in the chat. So multiplication kind of makes sense if you think about it in terms of concatenation. It's just adding 10 times or 100 times. So, but there are limitations. You know, it doesn't really make sense to multiply a string by a fraction, right? This will give us an error because it has to be a whole number from there. And this will not work. You can't add, you can concatenate two strings together, but I don't necessarily know what it means to add 10 to a string. So this will give us an error from there. Okay. And it's basically saying must be a stir, not an int, right? This must be, you can add two strings together, you can concatenate them. You can add two integers together, but you can't kind of mix them from there. Okay, and this is just showing examples of the conversion. This will take the string 3 and turn it into actual 3. This will take the string 3.0 and turn it into, it will not, right? Because what it's trying to do is it's trying to take the argument here and it's trying to treat it as literally an integer. This is not technically an integer. This is a string representing a floating point number. And so that is going to fail. That is going to fail. But it will work with floating point numbers from there. And vice versa, as we said, you can take any number and convert it back to the string. And this will return to you the string. And then this will return us the string, literally the characters. So what is that, right? That is literally the character symbol for 4, the decimal point character, and the character 5 from there, okay? So the thing that I kind of want to kind of take away with, you know, so there's different operations that we can do on strings. Oh, here's some fun things. I'm going to go off script a little bit. And so let's see. So if we have flavor, right, that's still defined for us, right? So flavor is a variable and it has the type string. And you know how tables, we can call operations on tables. We can do the same thing using the dot notation from that. And so one of the things that you can do is you can call upper on that. And so what it's going to do is, much like we're performing an operation on a table, we're going to perform an operation on the string, and upper happens to return a brand new string with everything capitalized from there. Okay. And so much like tables, it's returning a brand new string, And our original flavor variable is unscathed from that, okay? So that's just another example of using a dot notation. So I want you to, so now that we know about integers, we know about tables, we know about floats, we know about strings, I want you to start thinking about, especially when you have a name of something, I want you to start thinking that about these names of having types, because the type determines what operations you can do on that particular name, on that particular object. In Python, these things are called objects, and you can perform operations on these objects. And this flavor name has the type, and actually, we'll talk more about that when types, but it's a good lead in to kind of our next topic here, okay? Any questions on strings? We'll be using them to kind of display output for this class. All right, that will wrap up this topic. So I will stop our record. Okay. Great. All right. So now we know about our different types. And basically every name, every value has a particular types associated with it. And we've actually seen 5 types. This is right. So we've talked about the 4 that we've talked about. We talked about integers, floating. We talked about strings. We talked about tables, and we've actually talked about built-in methods or functions. These are things like we saw the str function, the int function, the float function, and here's another example of one, the ABS, the absolute value function. And so there is a command, and I'll show you an example of this, where you can actually, if you give it a value, or give it a name, it will actually tell you the type, and that function that does that is type from there. And so for any expression, its type is actually based on its value, not how it looks. And so what do I mean by that is we have x equals 2. So we have assigned x to have the value of 2. And if we do type x, that is going to return us an integer. And let's see an example of that here. Okay. And so again, we can take any expression, any value, any name, and get its type. In this case, we're giving it an integer 10, so its type should be integer, and it is. And now that we've assigned, in this case, we're assigning the integer 10 to the name A. Now we can type, we can get its type, and that will also return an integer. By the same token, we can get the type of 4.5, which is float. Interesting question. What would be the type of this? Would that still be a float? It would be a string, right? That really makes the difference. So strings, even though if a string looks like 4.5, even though it looks like a float, it is not a float. It is an actual string from there, and that will show us type. Here's an example. Right here is the demo that we looked at. We're reading in that table. We're taking that file name and reading in that table. So that's going to create a table, and then we're going to perform. So that is a table, and then we're going to perform the relabeling operation on that table, and so that gives us a new table. So we're creating, this operation is creating 2 tables. It's creating this table, the original table, and then it's creating a new table that's going to be relabeled, and then we're assigning it the name NBA. And so if we check the type of NBA, we're going to see that it is a table. And in particular, remember this import that we did up here? This import imported the data science library, and part of that library is this table object. This is a library, this is a tables object, and this is a table object that we can use. Okay. Another type of object we haven't talked about yet, but when we talk about how computers make decisions through if statements, we're going to talk about a name that either holds the value true or false. In computer science lingo, that is known as a Boolean. And so this is the symbol true, and we can also have the symbol false. From there, we'll come back to that. We will come back to that. And then the last thing that we saw was these built-in functions. And so the function name is actually just a name of a function object, just like everything else in Python is an object. So you can actually get the type of the absolute function. And it tells you it is a built-in function from there.
So are min and max built-in functions too?
Absolutely. Yep. And so if we did type min, built-in, and max, and there's a handful of these built-in functions, and max is one of them as well. So basically, you're going to get functions by either having them built into the stock default Python, or you're going to use these import statements. And so in this case, we're importing the numerical Python package, and we're just giving it a handy name called NP. And we're going to see that by using the dot notation, we can, when we talk about arrays, which are coming up next, we will unlock some of these operations that we can do from there. So functions are either going to be built in, or we're going to get access to them by importing from a library from there. And the number of libraries that we import is very small because the data science package gives us, between data science and NumPy, that gives us, I think, pretty much 99% of the things that we're going to need for this course from there. Okay, great. All right, let me stop the recording here, and I'll introduce to you arrays. We won't have time to finish them,
Okay, all right, yeah, so let's get started. I think Jason told me that we're almost done from the data types. So I guess we covered numbers, strings, and types, okay? And then the last topic is gonna be on arrays, and we're gonna pick that up from here. All right, so for arrays, many of you, I guess everybody I should say, have already worked on it to some degree. And we're just gonna go a review, but also like a view of the method that we have seen in the labs before, okay? So an array contains a sequence of values, okay? There are a few features of arrays that we need to take care of so we don't get confused later. And sometimes if you run into any kind of error messages, it's probably one of the cases here that we forgot, okay? So the first one is all elements of an array should have the same data type. Okay, so we talked about types before, like strings or numeric. So if you're looking at an array in particular, all of the elements should have the same type. Okay, one thing to recall in this case is that when we're working with data table, if you remember, like each column, right, is an attribute or it's a variable, and they all have the same data type. Okay, so let's see the examples from last week. Let's just see the ice cream cell. If you remember, like the different flavor, and then the different price and different color, things like that. So all of them, if you think about those columns, they're a particular attribute of each observation. At the same time, they're all from the same data type for each column. Then if you're doing any kind of arithmetic computation, it's going to be applied to each element individually. Okay. So if I have an array and then I multiply like with numbers, like say 1, 2, 3, 4, if I multiply that with 2, then I come to a new array of 2, 4, 6, 8. Okay, so that multiplied by 2 is being applied to each of the elements there. Moreover, you can see more arithmetic we can do here. When two arrays are added, okay, they first of all have to be the same size. Okay, otherwise you're going to run into an error message. And corresponding elements are added in the result. Okay, not surprisingly, and we're going to see a demo soon as well. Lastly, pretty important is that I was using the array example earlier, like the column example of a table. In fact, if you're using the column method from a table, you're actually going to get that entire column in terms of array. Okay? So with this in mind, let's go to our first demo today, which is going to show you. So it's on topic 3 here. Okay, so open that. All right, first and foremost, always load the library, and because otherwise you'll keep constantly getting into error messages. Okay, so here's some examples about arrays, okay? So the one thing that we didn't show in the slide earlier is that you can always make your own array, okay? So if you see, we're using this method called make_array, and then I type in the element that I need. And don't forget that I assign to some object. In this case, I name it as my array because later I can do manipulation about it. Okay, so I assign this and it's going to be array of integer here. Okay, 1, 2, 3, 4. All right, let's see one of the properties we were talking about earlier. Any kind of arithmetic being done to the array is going to be done to each of the elements. So when I multiply by 2, okay, 2, 4, 6, 8, okay. Remember this notation, okay? This is the power, okay? We're raise each element to its power of 2. So here we're going to get 1, 4, 9, 16. Another example, if I add one element, in this case, still doing arithmetic, we're adding 1 to each of the array. It's pretty straightforward. You're just going to do my array plus 1, and then that add 1 going to be added to each of the elements. Okay. Lastly, this I think we are all getting familiar with now is that we never touch my array itself, right? We're doing multiplication, we're doing power, we're doing addition, but we never touch my array. So if we still look at my array itself, it's still going to be 1, 2, 3, 4. Okay. Of course, if you think any of this you're going to use later, then what you can do is my array new, my array, and I just name it differently. Okay. And then later I can access my array new here as well. Okay. So this is just an example.
I have a quick question.
Go ahead.
So, wait, so you're making a new array here. So if you want to add another integer or whatever it is you're making an array of to the original, you have to make a new array. There's no way to add on.
Yeah, no, that's a good point. So yeah, so okay, so Shell's question, and I can demo it here. So what if I do this? Okay, so earlier the example that I gave is that, okay, I guess that's a relatively good practice in general. Like you don't want to touch the original thing, right? Like if I try to create a new one, I better assign it to something new. So, well, I guess the one, okay, let me show this. The way that I'm doing here, once I add the underscore new, is that maybe later I want to use my array and my array new, okay? If that's your goal, then you better name it in a different name and then do it. However, what Xiao was asking is, what if I do this, okay? So this is saying that my array add 1, right? So we're gonna get 2, 3, 4, 5, and actually assign it to the same name as before. So if I do this, I think we still gonna have everything fine, but then if we return it, it's gonna be 2, 3, 4, 5. Okay, so yes, so this is a lesson, I guess here, is that you can always rename your original object. And if you don't think your original object, like 1, 2, 3, 4, I don't need it anymore, so you can always do this, okay? But if you want to use both later, then it's a better practice to choose a new name for it, okay? But regardless, if I run it once, like we just done, then it's going to be 2, 3, 4, 5, right? And if I run it again, well, not surprisingly, I'm adding 1 to each of the elements one more time, right? So this time I'm going to get 3, 4, 5, 6. Okay, great question. Thanks. So let
I
me,
have a question.
oh, go ahead. Yeah.
What if you want to change, well, if you want to change the size of the array, like for example, now it has 1, 2, 3, 4, could you just go back into the originals and make it 1, 2, 3, 4, 5?
Yeah,
Or,
right. I think, yeah, in that case, you always need to go back to how you define it in the first place. Okay. Yeah, so this example here, what Samantha was saying is, okay, I do my array now, and then my new array now is 1, 2, 3, 4, 5. Okay, and then whatever follows. Okay, sounds good. So just to make my later examples working, I'm gonna turn everything back into 1, 2, 3, 4 and rerun those lines up until here. Okay, all right, thanks. All right, so continue here. So this is when we are manipulating each element by some kind of arithmetic, okay? By like a multiplication, by adding a, let me actually do this one more time. No, I should have done, okay, let me rerun it because I think I didn't change that line earlier. Okay, so I still have, okay, yeah. And now we're trying to demonstrate the other arithmetic that we mentioned in the slide earlier, is that what if I am adding 2 arrays together? Okay, so remember, if you want to add them up, you need to first of all have them in the same size. Okay, otherwise you're gonna run into some issue. So here we're demonstrating with another array, we call it another, okay, use the make underscore array function here. And then this new array is 5, 6, 7, 8. Okay, so I run that and I add them together. It's just gonna be the element-wise summation, okay, based on what we had done. So it's gonna be 6, 8, 10, 12. because it's 1, 2, 3, 4 plus 5, 6, 7, 8. Okay. And this is an example of what if you don't have the same size, then it's going to give you an error message. Okay. And sometimes the error message is useful, like here, operands could not be broadcast together with shapes. Well, I guess maybe not so much, but then if you look at how they're describing it, I think this is saying that one of the arrays has 4 elements, whereas the other ones only has 3. So when you do the summation, it doesn't work. Okay. Okay, cool. So now let's look at some arrays of different types. Okay, so far we're looking at integers or numeric values. Here, let's make an array of different strings here. Ha, hey, ho. Okay, and what this happens actually is that this kind of arithmetic really only makes sense to what we had done earlier with the integers. Okay, when you do this kind of multiplication, I know if you do like string at a time, you can do the multiplication, but once it's put into an array, I think only certain types will work. And then usually it's the type that we're familiar with, like say numbers and stuff like that. Okay. All right, so this is string array. We can initialize string array, but then the manipulation that we can do with it is quite limited. Okay, still, it's useful. Like if you remember the ice cream cell example, that we have certain columns, right? Like say the flavor as well as the color, then those are definitely string array. Okay, so it is still useful whenever you're making array of a different data type. Okay. All right, so now we come back to my array, which is 1, 2, 3, 4. Okay, so other arithmetic you can do. Functions such as like sum can be applied, and max, and then absolute value, things like that you can think of. Okay, so sum, when we do that, 1, 2, 3, 4 add up together is 10. Okay, and the average, so maybe this is the first time you have seen average. We're using the average function from the MP library, where we have loaded at the beginning NumPy. Okay, we do, if you remember, import and then the name of the library. And we can always use a short form for it, so we don't need to type the entire name every time. So typically people actually, NumPy is really widely used, and people like to use MP for it. Okay, so the average function that we're doing here is from this library. So remember, if we do that, we always use the dot after the name of the library and then type the name of the function. Okay. So if we do that, well, it's 2.5 because total is 10, right? The sum is 10. There are 4 elements, so the average is 2.5. Okay. One last thing, you can always return the length of an array. Well, this might not be as interesting here because we actually create the array ourselves, and we know that it's 1, 2, 3, 4 is 4 elements. But sometimes you might be dealing with a really long array, and then you really just want to get a quick count out of it. Then len is a good handy function that you can use. Okay. Yeah, so again, the demo is available on our course website, so feel free to check it out. And one last thing I want to demonstrate in this demo is that if you remember from the slide, we're highlighting that a column of a table is an array. Okay, this might sound intuitive since I was using the example about the ice cream and I think about each column and things like that. But let's get into it a little bit deeper, because there are 2 different functions that we can use on tables. I will just highlight them now, so we're going to see it soon. One is select. You have seen this before. We're selecting certain column. Okay. The other one is column. Okay. So one of this going to actually return us another table of those column, like the particular column that we like. The other one actually going to return the array. Okay. So it depends on what we're going to do or what you're going to do with it later on. You might choose one or another. Okay. This is just a highlight overview, and let's now get into the specific examples of NBA. If you remember the NBA salaries, I think it's season 2015 to 2016. And then it has different, I think, positions of the players, different team names, and then salary, et cetera, et cetera. Okay. So, okay, actually, let me just show it, right? We have NBA show. Let me just do the first 4. Okay. Yeah, if you remember there's also the player name. Sorry about that. So we have the player name as a column, position of that player, the team, and the salary in, I think, $1 million. Okay, so just to refresh your memory, this is what we worked on before. All right, so this is reviews, but also preview and overview of how to use arrays in terms of the columns of tables. So if you remember the where Okay, we are selecting, remember, where has 2 inputs, right? We're selecting the team, which is Golden State Warriors. Okay, so in order to select all of the rows only about team Warriors, what we do is we use NBA, that's the name of the table. We do dot, and then we use this where first input team, second input is Golden State Warriors. So if we do that, then we're left with, and don't forget I had assigned it. You should always assign it to something that you're gonna access later. So here we call it Warriors, just the name of the team. And then so you see that now this entire table that we're seeing over here only contains the rows about Golden State Warriors team players. Okay, so this is the first step. Okay, and okay, so my demonstration here about the column, whether column is a column or column is an array. Okay, especially what you're gonna do later is here. So if you do select, which I think we have done before in the lab, that we're trying to create a new table, if you remember, like only selecting certain columns, then if you want to do that, you're going to use the select function, because once you do it and if you return it, you can see that it's still going to be printed out in a column format. Okay, so for example, if I now want to assign this to a different object, say like warrior salary, something like that, then I can do that. And then if I access that object, it's going to be giving me a table with single column. However, if you use the column, sometimes it's useful. The column, the dot column function here is actually going to return the entire column as an array. That's what we mean by actually the column can be returned as a data frame if you want to use it later as a data frame. Or if I do, which we're going to demonstrate in a second, if I want to do certain kind of summary of that particular column, then I will probably use the column method. So let me return that to you. So you're going to see immediately here. See here? Once I do the column, it shows me that it's going to be an array, okay? And it prints out the values for each. Okay, so see how the two different from each other, okay? And also, like I said, doing the select, you might use it later, especially if you're going to select multiple columns to create a new data frame. That's what we usually do, use the select. Okay. However, if you want to do summaries, like what we're going to see soon, like if I want to know the average salary of Warriors players, if I want to do that, then the np.average, that method should be applied on the array, okay, not the column itself. That's why it could be useful that you're going to use the warriors.column in order to return the whole column as an array. Then I can do all kinds of arithmetic about it if I want. So this, again, we covered this in the arrays lecture because, well, we first of all talked about all of the arithmetic you can do, right, about an array. And then now in terms of like now moving from CS to data science here, then we're thinking about how to summarize particular columns, especially numerical values here that could be useful. Then we still focus on the idea of array. So in order to get the array, we can use the dot column method. And then we can do all kinds of arithmetic we're curious about. Okay, so if I run this, it's going to give me the average, okay, 6.7 million on average for the Warriors team players. Make sense? Make sense? All right, last demonstration is what if I'm curious about the difference of the average salary of Warriors compared to the average salary of Toronto Raptors. Okay. So to do that now, okay, we already did np.average of the salary of the Warriors, right? And now if we want to compare it against Toronto Raptors, we can do where again to select a team which is Toronto Raptors. And we assign it to a object, which we know it's gonna be a data frame about Raptors only, okay? And then lastly, we doing the dot column method on the Raptors as well. And then from there, we can do the average, and then we take the difference of the two in order to get the answer to what we were curious about earlier. What is the average? What is the difference between like the difference of the average salary between the two teams? Okay. So you can see that we always use the dot where to select certain rows, satisfying certain conditions. Okay. And then in order to do arithmetic manipulation on numerical columns, Then we are doing the dot column method to turn it into an array. And then we do our arithmetic based on that. Make sense overall? Okay. Yeah, sounds good. Like I said, I think some of this we have seen, but then now we get the chance to formally talk about what we mean by arrays and then all of the details here and there. Okay. All right, sounds good. Any quick questions before we move to our new topic of building tables? Okay, now, okay, sounds good. Let me stop recording here.